Hey folks, welcome back to my channel. I'm Kaidoku. I'm going to walk through showing how to train a WAN 2.2 LoRa using Musubi tuner via my RunPod template. I'm going to link my template below if you guys don't have it already, but let's get going. So once you launch the template, you're going to see this. You have your options of tools to use. We're going to kick off Jupyter Lab. Once you click on that link, this is where you're going to get to. So the first step we're going to do is set up your data set. You're going to go into data and we're going to open up a terminal. So now there's a couple ways that you can upload your data set. You can drag and drop a folder in here that has your data set in it. You do want to upload a folder that has it in it, not upload your images and captions directly into this location. You want a folder. So you can drag and drop the folder if you want. Sometimes Jupyter Lab behaves weird. Doing a drag and drop doesn't always copy everything over or corrupts the files. So I don't use that method. I upload it through the terminal, which is how I'm going to show you today. The method I use to do it through the terminal is using a tool called gdown. In order to do that, you need to install it first. I'm going to link this command below. You're going to run this. You're going to see it install gdown. The next thing you want to do is on your computer, you want to prepare your data set in a folder. And this folder you want to compress into a zip file. You want to take the zip file and you want to upload it to your Google Drive. So it looks like this. Once it's in your Google Drive, you want to right click on it. You want to click on share. And you want to make sure the general access, it says anyone with link can view. You're going to copy that link, hit done, go to a scratch pad or wherever you are noting things down and paste it in there. All you need from this URL is this alphanumeric value right here in the middle. You're going to copy that, go back to your Jupyter Lab, and you're going to do gdown and paste. And then that's going to download that demo underscore dataset.zip that I created, and you're going to see it here on the left hand side. Once that's done, you're going to right click on it, you're going to do extract archive, you're going to give it a second or so, and it'll extract it. Then you're going to clean up any residual garbage here, so I'm going to delete this because I don't need it. And I'm going to delete the zip file because it's no longer needed as well. And this is what you should end up with, your folder with your image and captions inside of it. I'm just doing 5 images just as a demo for you guys here today. Your data set should definitely have more than 5 images though. Once you have it looking like this, your data set is ready for training. You're going to go back to the root folder, and now we're going to go into the Musubi folder, and we're going to open the config.sh. Now feel free to change any of these settings that you want. These are the settings that I use to train. They work well for me, but feel free to play with it, experiment with it, see what works best for you. One thing you do want to change in here is this right here. You want to make sure that it is pointing to the folder you uploaded. Since I uploaded demo underscore dataset, I'm going to leave it as is, but your folder name would go here. And then where it says title high and title low, these are the file names that your LoRa's will have after training. So you can name it whatever you want. I'm doing demo high and demo low. And then you're going to do save and close this out. You want to open a terminal at this point, and so we can kick off training. Now I built its process out to be super simplistic, very little steps, where all you're going to do is upload your data, whether drag and drop, using gdown, whatever works for you. You go into Musubi, update the config file, save it, open up a terminal, make sure you are in the Musubi folder when you're in this terminal, and just type in bash train.sh, hit enter. So one thing you want to note when you kick this off is going to detect how many GPUs you have. The good thing about this tool is that you can train the high and low noise LoRa at the same time if you wanted to. You just need to kick off your RunPod with 2 GPUs attached. I usually use 2 H200s, and in that case, when I do launch train.sh, it'll say detected GPUs 2, and it'll automatically go through the flow of training both the high and low noise at the same time. Right now I'm running just a 6000, so it only sees 1, so it's going to give me an option. What do I want to train? This is what you're going to see. Which WAN 2.2 model do you want to train? High noise, which controls motion and structure. Low noise, which controls detail and likeness. For the purposes of this demo, we're going to use this LoRa to do a text to image flow. You can do text to video as well. For text to image, there are workflows that only require one LoRa. For that, you can use a low noise LoRa. There are text to image flows that you can put both the high and low. If you have both, I recommend using both. We're going to choose 2 here just to get things flowing so you can see how it goes. Once you select whichever model you're going to choose first, it's going to go through loading the models for you to start training. Now, the good thing about this template is when the first time you launch it, it's going to download all the models for you already. So you're going to have all your WAN models already in the system. If you have an attached network storage, which I recommend you use, everything's going to be saved in there from the get-go, which saves a lot of time in just getting things going. Once you see these epochs popping up, as you see here on the screen, that means my training has already started. So it's very little steps to get going, very little to change. Upload your data set, modify a line or two in your config, kick off training, and just sit back and wait. If you have a large data set, 30, 40 images, which is a good data set, obviously this may take an hour or so, maybe a little bit more. So whenever you see these epochs, you know it's a good time to step away, do something else, come back and take a look at it in a little bit. I'm going to go off and cancel this because I already did this, and we're going to go on to the next step. So in this process, we trained the low noise. If you want to train the high at this point, you can just kick off train.sh again, and just choose high noise as your option, and it'll do the high noise for you. Once you've completed training both the high and low, you want to go back to your root folder here, and you want to go into your outputs, and you're going to see a Musubi WAN 2.2 folder. You go in this folder, you're going to have a high and low folder, and your trained LoRa's will end up in here, the high and low models. Once you get to this point, your training is done. Another good piece about my template here is that not only can you train, but you can also test these models out. So what you're going to do for that is you're going to right click on your LoRa, you're going to do copy, you're going to go back to the root, you're going to click on apps, comfy UI, models, LoRa's, and you're going to paste it in here as well as the high noise model. You're going to go back to your pod and you're going to kick off comfy UI, and that'll take you here. Now this template, this workflow that you see here on the screen is a workflow that I created for text to image using WAN 2.2. If you guys want it, just send me a comment, hit me up. I am more than happy to share. But I have it up right now just so we can test things out, so I can show you how my training went with the 5 images that I uploaded. Whichever workflow you use, you're going to upload your LoRa's. If it has both a high and low noise, you're going to upload your high, your low. If there's an upscaling flow to it, I do recommend you use a LoRa model. LoRa is there as well, and load the low one there again. Sometimes when you do upscaling, it can change the face of your character. Adding this LoRa loader here along with the upscaler to the K-sampler will help maintain the character face that you're looking for. So once you have your LoRa's loaded, you have your prompt, we're going to kick it off. So we're going to pause here for a second while this goes, and I'll show you the output in a minute. And we're back, folks. So as you can see here, this is my output from this training. Just to give you guys a reference point, if I show you one of the images in my data set. So this is one of the images from my data set. And as you can see in this test with only 5 images in my data set, the likeness is pretty good. If I had a regular data set, 30, 40 images, I'm sure it would be much closer, but for this purposes, I think it's not bad. And that's pretty much it. Your training is done. You've created a high and low noise WAN 2.2 LoRa that you can use for text to image or text to video, whichever you prefer. We'll link below my template, and I'll link below the gdown command if you want to use that going forward. Comment, follow, let me know what you guys think. But thanks for being here. Thanks for watching. I'm going to be uploading other videos in the near future, how to use AI Toolkit, which is also part of my template here, and how to train other models, at least the way I do it. Thanks again for watching, guys. Talk to you soon.